All right, so let me share my screen again and show you guys a couple things. After we finished that problem, and I was looking at it during the break, I was going, I wrote, we wrote a problem, but this problem actually didn't match the objective that we were looking at. I think the problem was I was talking about double angles and giving a 2x example, and then kind of jumped ahead to that, which this was actually one of the requested problems to look at. But just to note, this was not an equation. So I just want to clarify that in case those of you who are watching later are going, wait, that's another objective. It is. So we'll go back and do an actual equation now that we've looked at these double angles, but you kind of get the idea that all of this really goes together. The idea of using one trig value to find the other 5 and then incorporating double angles and then looking at a trig equation, they're going to feel very similar. So this actual problem went in 5.5. It was this objective, evaluate a double angle using a double angle formula. So that problem that we just worked was a 5.5 problem. And 5.5 is tied to 5.4. So let's just talk about these two, and then we'll go back to those trig equations, and I'll show you an actual question that we had out of 5.3, and then look at the Desmos activity for solving trig equations. So yes, I think we've covered this one pretty well with those double angle formulas. Now, in terms of 5.4, using those sums and differences, you had fewer questions because the sums and differences gave us the double angle, and they are important. They help us solve equations and identities, but you didn't see as many questions, right? Not as many tricky parts as you saw in 5.5, like the one we just did. So make sure you write down your sum and difference formulas for your sine of u plus v, and cosine of u plus v. Make sure those are on your note card in case you need to see those. I didn't get any questions out of this section in particular, so I'm going to go back and spend our time more on this section. So again, this was not an actual trig equation. So let's look at one that was. Okay, so one that you would see in actually 5.3 might be something like this. And the directions in this case are going to be to solve. And in particular, you're going to see solve, and sometimes they say something like write a general solution, or sometimes they'll say only give the answers between 0 and 2 pi, or in this case where your b is not 1, maybe 0 and pi, something like that. The general solution is most common with this particular type, and we're going to see why in a second. But the one that I picked that actually goes with our Desmos activity is the equation 2 sine of 2x equals 1. Oops. So in this particular case, even though we just studied double angles and we know how to expand sine of 2x, and we could write an expansion using your double angle formula, that's actually not going to be the best approach here. When we're thinking equations, kind of tying back to the rest of 5.3, your general approach is going to be, if you can isolate the trig function and just have one trig function, that's going to be your best bet. So sometimes this involves using your cofunction identity to convert a cosine to sine. Sometimes it involves quadratic, where you have like a sine squared and a sine, and you have to get sine by itself using factoring and having 2 factors. Other times, notice we have this 2x, but we want to think about that as our general angle. So if we can isolate the sine of 2x, and then we'll deal with the 2x as the last step, that's going to be our best approach here. So really, solving this trig equation, if it were just a 2 sine x equals 1, would not be a problem. We would go ahead and, as our first step, divide by 2. So sine of 2x equals 1/2. And then I just want you to think about this part as an angle. So we're going to think about what angle gives us a sine of 1/2. Now, if we think about unit circle, always thinking back to unit circle, we have a place where our sine is 1/2 in the first quadrant, and then we're going to have a positive sine value in our second quadrant. They should look a little more symmetric. But the angles that we're looking for, where our sine is 1/2, is pi over 6 and 5 pi over 6. So that means the angle, think about that as the angle we're looking for is either pi over 6 or the angle we're looking for is 5 pi over 6. Then go back in and think about, that's actually giving you 2 equations now to solve. Now, I wrote in this case, if I were looking at my unit circle, but when you're writing your general solution, and this is where the Desmos activity maybe does it a little bit differently. One way to think about this to get that, instead of plus 2 pi n plus pi n part correct that we're going to have show up in this one, is to go ahead and put the plus 2 pi n here at this step. In other words, the plus 2 pi n was when we were looking at angles, or excuse me, angular speed of 1, right, where b was 1. So if you don't have an angular speed of 1 and you have an angular speed of 2, that plus 2 pi n gets cut down, and that's the tricky part. So if we think about organizing it by adding that plus 2 pi n, now when we divide everything by 2, that's actually going to take care of helping us remember that instead of plus 2 pi n, we get a plus pi. So in this case, pi over 6 divided by 2 gives me pi over 12, and then plus pi n, and then 5 pi over 12 plus pi n. That to me might be a little bit more streamlined than how I showed you to do it, kind of just focusing on the angles and then cutting the 2 pi n in half and adding the pi n at the end. Now, this problem was actually one of the ones in the solving Desmos equations, but I think in some of these cases, it's better to just go to paper and draw yourself a little bit of pictures. In other words, the Desmos activity, the way they were doing those blanks may have clicked with you, or if it didn't, that's okay. Sometimes when I'm doing those, I end up feeling like, I'm gonna share this page, that those blanks make me more confused, and that's not what we want to happen. So let me get that Desmos page up. There we go, guys. Okay. And the slide that we're actually going to is slide number 10. And I'm actually going to go to the student view here. Make sure I'm on the right one. Okay, apparently I put myself on the wrong one here. Yes, we are going to come back to 10. Actually, I think this one was the one, sorry, this was the one on 12. I did this one first, and then we'll go back to 10. So double angle or angular speed greater than 1 within a trig equation, notice what they did. If you refresh this may work, we'll see. This is one that they were walking you through step by step. So if 2 times sine of 2x equals 1, they were walking you through the dividing and then splitting it up that first way. So we were looking for a pi over 6 angle whose sine was 1/2, and then a pi over 12. Or excuse me, this came out to be pi over 12 when divided by 2, and then plus pi n. Now, this is actually, in this particular part, this is only the first quadrant part where we started with pi over 6. What they're wanting you to do in this next question is, and I think this is maybe the confusing part, they were wanting you to take the second quadrant original angle whose sine was 1/2, the 5 pi over 6 angle, and give the n solution. So when we started with the 5 pi over 6 angle, when we divided by 2, we got 5 pi over 12 plus pi n. Now, the confusing part to me when I reread this question was, well, 5 pi over 12 is not in quadrant 2, but it was the one that originated from our quadrant 2 solution, if that makes sense. So the one they're wanting is this one, right? Now, again, if that confuses you, you're not going to have this verbiage on the actual test. It'll just be solve this equation, right? 2 sine of 2x equals 1, and you'll be giving those solutions. So that was one of the specific ones to look at. Let's go ahead and look at 13 and 14 briefly, and then we'll go back to number 10. Number 10, I believe, does not have a double angle. So we're kind of picking the hard ones first. In other words, if we can tackle this, hopefully we'll be able to tackle those ones. So let's go ahead and take a look at this one. This one, they tell us that correct answer that they're looking for. And again, don't let those quadrants confuse you. So in this particular example for slide 13, instead of a 2x in parentheses, we're going to have an x over 2. It's going to be a similar idea, but instead of dividing by 2, we're going to be multiplying by 2 in that last step. So let's go through this one. And if we need to switch back over to the iPad, we can. But we're going to divide by 2. So we have the cosine of some angle is -1/2. So what we want to do is figure out that angle, and then we'll tackle the getting rid of the x over 2 part. So in this particular case, the angle we're looking for is 2 pi over 3. So keep in mind, if you have a negative cosine, you could be in quadrant 2, or you could be in quadrant 3. Okay, so they're going to do one of the examples here, and they're going to ask you for the quadrant 3 solution, the other one. So if we have 2 pi, and I'm going to write it down on paper as we talk about it, and then I'll share if we need to, because my brain has to write them down. So if we think about 2 pi over 3, let's see, 2 pi over 3, then we're going to multiply this by 2 to get our x by itself and the other part. So we're going to get x equals, and then if we multiply by 2, 4 pi over 3 plus 4 pi n. Okay, now if we want to think about, and this is where I'm writing on paper, maybe I'll just stop the share, write it on the iPad so you guys can see what I'm thinking. Sorry, my share is a little slow. I think my internet's lagging a little bit. Hopefully it'll be okay when you guys are watching it back later. But on this one, when I'm thinking about my 2 pi over 3, 2 pi over 3 is a terrible picture here. My 2 pi over 3 is in quadrant 2. And I can kind of think about my pi over 3. 1 pi over 3, 2 pi over 3, so I'm here. And this is going to get mimicked in our third quadrant. So in other words, the other angle we're looking for starting in quadrant 3, that was our 2 pi over 3. And this guy, we're going to go to pi and then add another pi. No, hold on. No, I added one too many pi's, guys. So back up here. So this is 2 pi over 3. Here's 3 pi over 3, or pi, and then 4 pi over 3. 5 pi over 3 would be in quadrant 4. So the other angle we're looking for is 4 pi over 3. So let's go ahead and think about how to transform that. What's going to happen in this next part, and this is the tricky part, I think, is that it's not showing you the in-between steps. So what we need to do is think that x over 2 is now 4 pi over 3 plus 2 pi n. So we're still going to need to multiply the 4 pi over 3 by 2 to get 8 pi over 3 plus 4 pi n. Okay, so we have to do that last step and go through that paper and pencil work. Now, the last one with 14, that was a question on this one. I think this one also maybe if the idea of using the coterminal angle confuses you, just focus on solving the given equation. What they're wanting you to do is fill in the blanks and thinking about the explanations and what you would do. So in this particular one on the test, your problem might be just solve 2 sine 2x over 3 equals negative square root of 3. And keep in mind, have your unit circle handy. That's another thing you might want to stick on your note card, your special trig values. But go ahead and think in this particular case. The first thing I would do is divide by 2. I'll just do this. And then that's going to give me negative square root of 3 over 2. Okay, so then we have to think about what angle has a sine where we have negative square root of 3 over 2. So if I'm thinking about my unit circle, I know that I'm having a negative sign, so I have to be starting with an angle in quadrant 3 or an angle in quadrant 4. Then if we think about that negative 3 over 2 or square root of 3 over 2, that's going to give us something closer to negative 3 pi over 2 in terms of those ones. So it looks like in that particular case, we are looking to start with 4 pi over 3. So look at your unit circle and one of your angles in quadrant 3, 4 pi over 3. And then the other angle that we're looking at in quadrant 4, if you look at your symmetry, is going to be 5 pi over 3. Okay, so in other words, this isn't where we're going to end up, but we're starting really at these two. Okay, but what we have to say is 2x over 3 equals 4 pi over 3 plus 2 pi n. Then your other half that you'll get to in a second would say 2x over 3 equals 5 pi over 3 plus 2 pi n. So if we multiply by 3 halves, that's going to give me, and I think this was where I got confused on this one, because I didn't know what they wanted me to do in this next one. Like if I were doing this on paper, I would just go ahead and multiply by 3 halves here. I'm not sure what they want us to say here. Again, I may just be thinking about it in a different step than you guys, but I would probably say even multiply by 3, divide by 2. Let's just go ahead and multiply by our 3 halves. So if we multiply by 3 halves, you're going to get x. And then if you multiply by 3 halves here, the 3's are going to cancel, and I'm going to get 2 pi. And then I'm going to do 2 pi times 3 halves. Okay. Now, again, on this one, do some scratch work, right? And I'm going to double check it here to make sure I'm doing the right thing. But I've got 4/3 times 3 halves. So that gives me 2 pi. And then I'm doing the 3 halves times 2 pi. And that gives me the 3 pi. Put your n on the last one as well. So again, don't stress about this because I think maybe this got coded, like a step got left out. We'll look back and see what everyone else did, but that should be one solution. In other words, originating from that quadrant 3, we have 2 pi plus 3 pi n. Now, this is actually interesting because if you think about coterminal angles, your coterminal angle in this case is going to be 0, right? 0 plus 3 pi n. So if you were doing this on a test, I'm not sure which WebAssign would prefer, which one, but I would accept just saying 3 pi n. Because if you think about 2 pi plus 3 pi n, you're at the beginning of your circle and you're adding multiples of 3 pi. In other words, 3 pi, 6 pi, 9 pi. And that one originated from this. Then I think on the next one, they were wanting you to also think about your other part. So again, the other one that you're going to have is if you go back, let me stop this share. and just write this down. In other words, I'm not sure where they wanted you to put that other quadrant here. But if you look at starting with 5 pi over 3, and you go back to 2x over 3 equals 5/3 pi plus 2 pi n, and then multiply everything by 3/2. Notice here we're just going to get back x. Notice on this one, we're going to cancel our 3's, and we're going to get a 5 pi over 2. And then notice, very similar to the last one, our 2's are going to cancel, and we're going to get multiples of 3 pi that get added to us. So when we think about 5 pi over 2, 5 pi over 2 is the same as pi over 2. Okay. So that's, I think, what I was trying to ask you to think about with your coterminal angles. But then there wasn't a box necessarily. Oh, I see what they want you to do, guys. Sorry, I'm having a brain fart on this Desmos activity. I see how they wanted you to structure it. So again, this part, sometimes the Desmos part confuses me. Let me show you how they wanted you to structure it. They wanted you to go ahead and write, in this particular case, this is your quadrant 3. They wanted you to go ahead and finish it and write the 2 pi or the 2 pi plus 3 pi n here. And then what they wanted you to do, I see, is they wanted you to say quadrant 4, like starting in the quadrant 4 one. And then they wanted you to go ahead and do the 5 pi over 3 here. Plus 2 pi n, and then multiply by the 3/2 like we did. And then we simplified the coterminal angles, did this. So again, the Desmos box has clearly confused me, but what you want to get to is either 2 pi plus 3 pi n or 0 plus 3 pi n, and pi over 2 plus 3 pi n. On the test, I think, and on your web assignment, I focused, on ones that had like a 2x instead of a 2x over 3, just to make those a little bit easier, because we didn't do a ton in your practice with ones like this. So expect one like a 2x or a 3x, not necessarily as many fractions. So I know that was a little bit all over the place in terms of filling this box in, but hopefully writing that down helped, and thinking about the angles that we start with also help. And again, don't worry about the sketch tools if you are not seeing what they want you to do. So let's quickly go over to number 10. That was the last question that we had. And this is another one of those fill in those blanks that may or may not be so straightforward. So let's take a look at the equations that we are looking at. Oh man. So again, they're wanting it to be helpful by helping us out with providing some steps. But again, hopefully we won't go off course. So the equation that we want to solve that you would see is 2 cosine squared x equals 4 minus 5 sine x. And when I look at this one, the first thing that pops out of my brain is, hey, I have cosine and a sine. I'm going to need to go ahead at some point and convert both to sine, or either both sides to sine, both sides to cosine, one or the other. And likely I'm going to either need to use Pythagorean identity if I have the squared and I go that route, or I'm going to need to use cofunction. Those are the two tools that I have. And the way they've set this up with our steps, you can see they're providing us some guidance on what they want us to do. So our given equation, 2 cosine squared x, is our left side. And the first thing we could do on this one is use that Pythagorean identity. So if we wanted to go ahead and take cosine squared to a sine squared, we can do that. So we know cosine squared is the same as 1 minus sine squared. And notice that 2 on the outside needs to get distributed. But the right side, let's go ahead and fill it in together, is still 4 minus 5 sine x. Okay, and what did we do? Use the Pythagorean identity. Okay, you guys get the point there. And then distribute the 2. So we get 2 minus 2 sine squared of x. And then we're really not doing anything on the right side. And then notice what's happening here. This step, I've converted everything to sines. I didn't end up having to use my cofunction since I had the squared part. If you didn't have a squared, you would likely need to think about cofunctions and then possibly even an odd. I don't think you actually had any that did that, that I'm remembering off the top of my head. But notice here, if you have a quadratic equation, it's a quadratic equation in sine. So to solve a quadratic equation, get everything to one side, as if this were 2 minus 2y squared equals 4 minus 5y. If it were y's instead of sines, we would move everything over. So we can do this any way we like. I'm going to think about putting my quadratic terms first. So if I move over, if I add, I'm going to have 2 sine squared x. And then I already have my sine on this side. So I'm going to remember it's negative 5 sine x. And then let's see, I need to subtract 2, but I already have the 4. So that's going to be plus 2. Okay, so then next, or the description of that is going to be, let me make it, get equals 0. It's not very precise. What do I want to say there? And then on the next step, we want to go ahead and factor. So if it's going to factor, we're going to have 2 sine x, let's see, 2 sine x being plus 1, and then sine x minus 2. Again, on paper, put a y, kind of like we did in the video here, because this is going to give me my 2 sine squared. That's going to give me my minus 4 sine x. And then, let's make sure we're doing this right. Ooh, that doesn't give me the right thing. I need a minus, because I want my plus at the end. And then that was giving me a 3 and not a 2 in the middle there. So now I have negative 4 sine x minus 5 sine x, or minus 1 sine x gives me negative 5 sine x. So once this is factored, we still have equal to 0. And at this point, this is where our solution splits. So that's why they've added the third column. And they're going to set the left-hand side equal to 0, the right-hand side equal to 0. And at this point, we've actually done something very, very similar. We're going to take, and notice that there's no double angle. So life is easier. You're not going to have any where you're factoring and kind of have a double angle. I'm not going to do that to you. And you basically have these two solutions. So if you think about your solution here, this is going to tell you let's see. I'm going to go and add the 1 and divide by 2. So sine of x equals 1/2. Oops, 1/2. And then sine of x equals 2 on the side. Now, let's take a look at this one. This is interesting, right? Because we have this equation that says sine of x equals 2. And so what we're asking ourselves is, what is the angle where the sine equals 2? Well, sine output values are only between -1 and 1. So in this particular case, unless we see something that we've missed, we're not getting anything, right? That doesn't produce anything. Now, that can happen it didn't happen in every single problem. We could have solutions result from this. Let's look at our other side. If we looked at sine of x equals 1/2, that should be our pi over 6 angle. Oh, no. Yes, sorry, my brain is looking at a different problem here. So if we're looking where sine of x equals 1/2, that should be our pi over 6. So if we think about pi over 6, our cosine is bigger, our sine is smaller. And in this particular case, we're going to have pi over 6. And then we should go ahead and be able to do, this is just our first quadrant, go ahead and put the plus 2 pi in. And then also, if you had your sine was 1/2, you could be looking at an angle in your second quadrant. So 5 pi over 6 plus 2 pi in. Now, why did it leave blanks over here? Because you could have had solutions if this were something else, right? If this had been an x equals maybe something like 1, we could have been thinking about our pi over 2. And let's go ahead and check this, right? This looks like we have two solutions between 0 and 2 pi. Our coterminal or our sketch tools, we could sketch those out. But what I'm going to do to check it is just open up a blank Desmos page. And I'm going to jot down my original problem really quickly so I don't lose it. So I'm going to put in 2 cosine squared x equals 4 minus 5 sine x into the original calculator. In other words, before we started any cleanup. So remember, when you put it with an equals, you're going to get solutions that look like this. And keep in mind, right now, we're still in radian mode, but we could go ahead and adjust. Let's look from 0 to 2 pi. And then that'll give us just 2 solutions. And then the 2 pi n will take care of the rest. And then let's make these go in steps of pi over 6s. Okay, so we see our solution at 5 pi over 6 and pi over 6. If we're not sure if we got them all, remember that you can also do both sides. Like you can do y equals cosine squared x. Or you could suppress the y equals if you wanted. And then 4 minus 5 sine x. Okay, so notice where those two intersect are going to line up with those values that we found. All right, so that's a lot going on in those few problems. These are some of the toughest ones where we've got to use quadratic, and we had to use the Pythagorean identity in the middle of that, and then using modifying the 2 pi n when we had something like cosine 2x or sine 2x over 3. All right, so let's go back and I'll open it up to you guys for questions. I think those are all of the questions that were sent to me. And honestly, we looked at, if we think about our main 3 categories, identities, equations, and then sum and difference and double angles. We kind of hit all of them. We jumped around a little bit, but we did several identities. We've done several equations, ones that involved plus 2 pi n and plus modifying that 2 pi n. We looked at one example with double angles and then reviewed those formulas. So in terms of kind of a comprehensive review, we've done a pretty good job. Your test 4 is actually open right now. So as soon as you feel ready to take it, go ahead and do so. I mentioned that it will stay open until Friday night. So the sooner you get that in, what I'm going to do is kind of look each morning and see who's taken it, and then go through one by one and grade those as they come in and give you guys partial credit. So for example, this morning, I think there were 2 or 3 that had already come in, people that wanted to get ahead and take those over the weekend. Yay. But I'll go ahead and do those. And then as soon as I've graded your test 4 and updated all of your unit 4 test, I'll email you. because usually what I do is wait until everybody's taken it. But I know some of you guys are definitely waiting for your results to know if you want to take that optional test. So I'm going to try to do those as they roll in. So the sooner you get the test 4 done, the sooner I will email you. And what I will say is, hey, your current grade is this. Either if you're already at an A, your optional test or optional final is not going to help at all. So I wouldn't recommend taking it. But if you look at that grade and you are close to moving up a letter grade, then you want to take that into consideration. And I will open up the final exam probably tomorrow. I need to go through and make some edits and also release the list of topics for that. So if you are in that boat and you've already taken the test 4, then decide if you want to take the final and look in the final category. If you decide you're happy with your grade, then after you do that test 4 and all of your WebAssign and Desmos for Unit 4 is in, then that makes you done. Okay, so I know that's a little bit confusing, but I will be emailing each of you individually after I grade your Unit 4 test to let you know where you stand, so you're not wondering, has she given me partial credit or not, right, when you're looking at Blackboard and you're looking at your WebAssign. All right, so other questions that we have that we would like to look at? All right, so in terms of when I'm available, I'm not planning on having any more content that I give you guys on Wednesday, but I will just open up my Zoom for drop in on Wednesday. If you do have questions, suppose you're continuing to work on WebAssign and you have another question or two you would like for me to work out, definitely let me know. If it's something where you can't pop on Zoom, but you have a question, definitely email me, use the Ask My Instructor on WebAssign, and I'll get back to you either with a short video, sometimes that's a little easier, or some helpful tips. All right, guys, so I'll go ahead and end this meeting and get this uploaded for everybody else. But let me know what questions you have as you're working through, and good luck. Also, one last thing, make sure that if you've not taken the course evaluation, do that. I put in the email on Friday that I would give you guys 5 bonus points on your WebAssign homework average. I actually forgot to check before class this morning where we were. Let's see if I can pull it up really quickly. It only tells me the percentage of what percent has taken it. And I think we only had before Friday's email, I don't know if anyone had taken it in our class, maybe 1 or 2. They don't make it easy for me to find all the time where all this stuff is. But what I will do when I send this out later, I'll see what percent we're at. For some reason, it's not showing it to me right now very easily. Ah, there it is. So let me see. Sorry, guys, it makes me do a million clicks here. Let's see, for our particular section, we're at 51.85%. So 52%, we have 14 people who responded and 27 people who could. So again, let's try to get that up to 80% to get that partial credit or to get that extra credit on the homework. Again, it doesn't tell me who. So if you haven't taken it, jump on and do so. Encourage your classmates, remind them that that's there. I believe that will stay open at least through Wednesday for you guys. A lot of times they close on the final day of class. It may stay open until Friday, but try to get that done as soon as you can so I can go ahead and let you know and go ahead and add those 5 points, especially for those of you who end up being on the edge with your letter grades. All right, guys, so that will take us to the end of today. And I will see you in drop in. My little one is saying bye. You probably hear him. I will see you drop in Wednesday or email you if you are not in the Zoom or you don't have drop-ins. All right, thanks, guys.